Hello, my name is Nathan Campo. I'm a water resources engineer and principal with Bar Engineering. I'm excited to be able to talk to you today about the planning, design, and implementation of district stormwater management systems as a way to incentivize and spur redevelopment and development in our communities, as well as improve water quality. First, a little bit about Bar Engineering. We're located right here in Salt Lake City. We have offices throughout the United States and one in Canada, serving many sectors, including the public sector, where we do a lot of watershed management work. I'll give a quick overview of the presentation. First, I'll give a little bit of background on what district or regional stormwater management is. I'll further explain that with a couple of case studies, and then wrap up with a few lessons learned from years of district stormwater management implementation and some how-to tips. So what is district or regional stormwater management? Essentially, it's the management of stormwater through systems that collect, convey, and clean water, stormwater runoff in a way that blurs the lines between individual properties and between private and public realm. There's a drawing on the right that gets this idea across of stormwater being collected from multiple private properties, crossing a road right of way, and everything being collected and treated and stored, and in this case, treated and reused for irrigation in a collective way. It really, the underlying philosophy is to treat stormwater where it makes sense and to use it as a resource through the integrated and collective and larger way of treating stormwater. We're able to create value and reduce costs through increased efficiencies in treating water in a more collective way, and instead of treating it on a site-by-site basis. That also allows additional benefits that I'll explain and show examples of in later slides. There's also the economic incentives associated with encouraging redevelopment through providing plug-and-play stormwater systems, so that a developer or municipality can come in, develop a site, and just tie in to a pre-existing stormwater system that can meet all of their needs without placing the burden of stormwater management on that individual parcel. In terms of the size, I'll show a range of examples, but typically the treatment areas can be anywhere from just a few acres, maybe just a couple parcels, up to several hundred acres. And the examples that I'll show today are 8 and 122 acres. I mentioned the benefits, and there are many. Primarily what drives this is the cost savings benefit through a more integrated treatment in larger BMPs. We're able to have greater efficiency through creating one or two stormwater management features for a few parcels, as opposed to creating several. Those cost savings translate to the operation and maintenance side too. Now, there's just a single large BMP stormwater management practice to maintain, as opposed to several distributed. There can be increased water quality and flood mitigation opportunities as well. These systems can get rather large and can even be combined with larger water quality or flood mitigation goals to make improvements to the larger watershed. Again, by having a larger system, their habitat improvements, and often these are connected systems. I'll show an example of that can allow greater connectivity to other natural resources that are nearby. Along with that comes recreation benefits through the public realm expansion, opportunities for public art, of course, recreation. The economic incentives that I mentioned already, and through removing the burden of stormwater from a particular site, an individual development can have increased density on that site. This also opens up opportunities for the operations and maintenance for green jobs, and of course, as we always need to do, we need to meet regulatory requirements, and these systems can do that. Of course, the implementation of a district or regional approach is not without its challenges. Some of these are very real, and some of these are more perceived. And the biggest challenge is that in many places there's an unclear regulatory process, and that it's not clear who would permit or how this would be permitted, particularly when combining stormwater management between the public and the private realm. Who's going to regulate it? Who's going to maintain it? And who's going to pay for it? There's certainly the financing hurdles, particularly when there's phasing considerations. If the entire BMP or stormwater practice needs to be constructed ahead of time, but the development or even the public realm improvements haven't occurred yet, who's paying those upfront capital costs and even those several years of operations and maintenance before the development comes in and can help pay for that. Really, skipping down to the ownership and operations, it's really there can be challenging discussions around who will own, who will operate, and who will maintain. These are all challenges that can be overcome, but they take a significant amount of planning, and they take a champion. Often those champions can be municipalities. Those can be the planning arms of municipalities that are trying to encourage redevelopment. It could be a motivated developer who sees sustainability at the core of their mission, and maybe even a brand for the development. Or it can be a watershed organization when there's a champion available, and those organizations often can have access to additional funding sources, perhaps grants. And of course, water rights are something that have to be considered in any stormwater management project, any green infrastructure project, but they get even dicier when we're talking about multiple parties, multiple parcels, and stormwater crossing back and forth between landowners. So I'll dive into the first case study. This is in Minneapolis in the Prospect Park neighborhood, a new neighborhood that's being developed in a former industrial area called Towerside. The project was led by the Mississippi Watershed Management Organization, assisted by Bar Engineering throughout the planning and design over the past really decade. It's an 8-acre site that needed a lot of partners. There are a lot of partners at the table. The city of Minneapolis, of course, the Watershed, several developers, and the local park board and the county. A quick history here. The site is actually located in the historic Redevelopment Creek Valley. This is a waterfall and a creek that goes directly into the Mississippi River over the bluffs. Very beautiful waterfall. And the creek, however, has been buried through the long industrial history of this area. The project area is shown in the yellow outline. In the back, you can see the Mississippi River coursing through, going up to downtown Minneapolis. It was an area that's rapidly redeveloping with the addition of a light rail line. And because it was rapidly redeveloping, the cities of Minneapolis and St. Paul got together and developed a 370-acre innovation district where new practices that broke through regulation and red tape could occur, including this project. So at the core of this area was a new light rail station in a light industrial area that was changing over, and 8 acres of proposed housing with about 1,000 units was going in. And they wanted to look at managing stormwater and other utilities in a more comprehensive way. So we developed a study looking at the entire 370 acres at first, coming up with a water budget. How many gallons of water are running off each property on an annual basis? What's the water we have to work with? And then we zeroed in on one of the study areas that we identified and one of the opportunity sites that happened to coincide with that 8-acre parcel, or those eight acres of redeveloping area, multiple parcels. And this is ultimately what was constructed. So this was a formerly very industrial area. Now this is what the site looks like today. All of those buildings are brand new within the last several years, and they're all connected to the district stormwater system. And additionally, there's a new park that you can see kind of in the foreground to the left that was constructed by the local park district at the same time as the redevelopment. So I step through here. So first, the Green Line light rail transit line came in. That was the first driver. Then in 2016, we built the core of the district stormwater management system, shown in blue there. You can see the pipes connecting each of the developments, and two large rain gardens were constructed to clean all the runoff. And then the building started to come in and tie in to the system. First the link, then Green on 4th, followed by the Lewis, and finally last year, the Pillars of Prospect Park, a senior living facility, came in, completing all 8 acres. We have additionally sized the system to accommodate one future development that could occur behind the Lewis. That hasn't occurred yet, but when that property redevelops, they will be able to tie into the system and have their stormwater management needs taken care of. So what are the components? This shows the site map of the 4 major parcels that connect into the system. We're showing the conveyance system, the pipes that were constructed. Then there are the 2 treatment basins. Underneath the large treatment basin, we constructed an underground concrete tank that could store the filtered water for future reuse. And then we installed a reuse system to send the water back to each of the developments, but cleaned so that they could use it for irrigation. What some of the construction photos look like of the pipes and the biofiltration basins. There are 2 of those. The largest one created the core of a larger park, and the basin itself became a park. You can see the trails going through there. I'll have more photos of that in a few slides. First, in the underground storage, and then the vast network of reuse pipes coursing all throughout this neighborhood to bring irrigation water to those that needed to use it. And finally, just a quick summary of the costs and the benefits. It cost about capital cost in construction, about $860,000. For the system itself, that actually does not include the reuse system, which was a few $100,000 more, but it resulted in 15% lower cost for stormwater management as opposed to doing it site by site. So it was win-win-win for the developers and the Watershed organization, and it achieved some pretty good water quality metrics, reducing total suspended solids by 90% and total phosphorus by 60%, and providing over 4 million gallons of water for reuse each year. Created, of course, about a half an acre of habitat and incentivized redevelopment, creating a park-like amenity. So, of course, any system that we develop has to be maintained, and now BAR is helping the Watershed and the developers to maintain it. We are maintaining the reuse system. It's a UV filtration system for the irrigation system, and we're maintaining the tank. You can see the empty tank on the right. We've already had to do some repairs to that. The developers are paying into a fund annually for O&M, and we have not exceeded what they're paying in. So tracking pretty well on that. And the watershed is going to take care of O&M for the first 5 years, and after that, the developers will take over. And we anticipate that the overall cost for operations and maintenance will be less than if each of the developers had done this on a site-by-site basis. And so far, that has proven true. Here's some fun photos. Of course, I mentioned this was a stormwater park, and people are already using it as a park. Both adults and children have been exploring the stormwater park when it's dry, and learning about stormwater management and experiencing the public art that we've placed throughout the basin and around the basin. It's also served as a place for people to play and explore when it's dry, or even when it's starting to fill with water. And I mentioned it supports a new City of Minneapolis park, as well as a community garden. And there's a photo of the community garden and a structure that was built in the park that not only provides shelter for picnickers and community gardeners, it also houses the reuse treatment system, the stormwater reuse treatment system. And that system is being used to irrigate not only the community garden, it's also being used to irrigate the development. And we've even hired a contractor with a water tank that drives up and down for half a mile, watering other plantings that are in the neighborhood that don't have direct access to the water. I believe in 2021, the first full year of it being online, we used a couple 100,000 gallons of water. And 2021 was a drought year, a significant drought year, worst in a couple decades in Minneapolis. And really, this neighborhood was kind of an oasis of green because we had such a good amount of water stored for reuse. The second case study is across the river in St. Paul, and is a larger site. It's what used to be called the Ford site and now is called the Highland Bridge redevelopment. It's right across this is an artist rendering of what the site will look like when it's fully built out. The stormwater infrastructure is all in place, and the buildings are now just being constructed. But given it's 122 acres of redevelopment, it'll take a number of years before the site looks like that rendering. The Ford site manufactured Model A and eventually Ford Rangers, but closed in 2011. It operated for about 90 years. The site is 135 acres in total, but only 122 of that is developable. It's located right on the Mississippi River bluffs, directly across the river from the airport. Barr started working with the city and the watershed, and then eventually with the developer back in 2007 to help planning for the future of stormwater needs. These are some photos of what the site looked like at the beginning of Ford's presence on the site. And then eventually it was almost completely paved with about 86% imperviousness across the site at the time of closure. You can see what it looked like after the site was most of the site was demolished in the lower photo. On the site itself, there used to be a creek called Hidden Falls Creek. The Ford company buried that in a pipe about now almost 100 years ago. That pipe went to a waterfall that you can see in the photo on the left, and you can see the pipe above it, and it was the main source of water to that waterfall, beautiful waterfall that cascades down, goes into a channel in the Mississippi River. Because of the built-up nature of the site, there are extreme flashy flows, really degrading the quality of the creek downstream. So not only did we lose the creek on the site, we had a degraded creek down in the Mississippi River floodplain. So this provided an opportunity to daylight that creek and eventually restore the creek downstream. So we looked at a couple different options. We looked again at site-by-site conventional stormwater management. This shows a this is an outline of the 122 acres of the site and how that and how stormwater management could be distributed. We looked at a concept that really centralized treatment into a treatment spine, a green spine through the site, and had more above ground. The baseline condition would be primarily below ground treatment distributed, and the centralized option would be primarily above ground, meeting the same regulations, same requirements. So we then took a look at what the cost would be, and the costs were really similar. Actually, we found that constructing the more above ground, the centralized or district approach was a little bit less, 12.5 million as opposed to 13.5 million, but the operations and maintenance would be a little bit more. So this is some initial feasibility level estimates. I'll just preview it. In the end, a system that was the district system that was constructed was about $13.5 million. There's about 5 years of gap between the two estimates. So I'd say we were pretty right on with our estimate on the district system, factoring in inflation. We also then compared the two alternatives, again, the baseline and the district system, through a number of different sustainability lenses. So we looked at the embodied energy footprint, greenhouse and water footprint, and found that in all cases, doing a district system resulted in less energy, greenhouse gas, and water footprint, primarily due to the materials and the amount of materials needed to be used in construction. Doing more at the surface, having more plants, more topsoil, and less concrete underground resulted in better sustainability metrics. We then took a sustainable return on investment approach. So really kind of trying to quantify the triple bottom line. And this is a little harder to read, but you can see on the left, the cost is the baseline or site by site analysis, and the right is the district approach. Above the line, the green shows benefits, and then costs are shown on the bottom. And what we're showing is a cost to benefit ratio that's more than double by doing a district system. We quantified a number of factors: job wages, recreation value, water resource value. How connected can people be to the water resource, even an air pollution benefit, and weighed that versus construction costs. We really found that the district system provided a lot more benefits on the metrics that we looked at. We also compared the two alternatives to St. Paul's own sustainability indicators, and I won't go through each of these in detail, but they had about 20 factors, and on every single factor of measure of sustainability that they had established for the city and for this project specifically, the district system did better, with the one exception that there would actually be slightly fewer developable acres on the site going with the district approach. But the only reason for that being that if all of the stormwater management on the baseline or site-by-site level is handled underground, they counted parking areas that would be above underground stormwater management practices as developable acres. So even there, that's kind of a wash. In terms of the building square footprints, there was no difference between the two alternatives. So we came up with some initial renderings, showed that to the public, showed our analysis to the public and to City Council. And in 2017, the city adopted the Stormwater Master Plan into their zoning plan for the site. Ford eventually sold the land to a developer, and we were then hired by the developer to help realize the vision, working with the city and the Capital Region Watershed District, who had funded the previous studies. So in 2018, we started working on actually designing that plan. And ultimately, we designed a number of different components, several large pretreatment structures, 5 large filtration basins or rain gardens using an iron enhanced sand filtration mix, 2 large open water ponds, a daylighted creek section that also had a rate control component to it, 5 underground filtration systems and storage units. So we did end up installing, a good amount of underground infrastructure that probably has a little bit more of an, embodied energy and carbon footprint than what we had previously studied. So it's kind of a hybrid approach. But the almost the entire site is centrally treated, with some treatment happening in a smaller district system in the northwest part of the site. And all of the above ground features are integrated into parks, and actually most of the underground features are integrated into parks too. In fact, some of the underground features are underneath a dog park or a civic square or bike trails. So in all cases, we're trying to stack as much infrastructure into recreational amenities as possible. And we were able to restore a more naturalized and lower base flow to the Hidden Falls water feature that I showed you, as well as the creek, which will allow for future stabilization of that creek. And I previewed before, the project cost $13.5 million of construction fees. Just kind of jump through a few slides. Construction began last year and concluded this year. It's completely done, ready for the site to be built out. The buildings are just starting to go in, but it's going to be about a 10-year build out to realize the vision that's shown here in this image. And again, when the project is done, it will look like this. A few of these buildings and row homes are being constructed, but all of the water features and all of the parks have been completed. So essentially the central portion of this rendering is complete. As you can start to see in this image, even this was from 2020 and it was already starting to come along in the central water feature. This is what it looks like today. Again, so the central park and water feature are complete. The basin is starting to fill up and the developments are starting to come on each side. Here's a rendering showing, we are looking to the north, and this is what it looks like today. This is the southern end, or actually this is what it looked like in 2020, and this is what it looked like today. Again, you can start to see some of the construction happening up in the upper right-hand corner, and it's ready for visitors. It'll open to the public in the spring of next year. Here's the Daylit Creek artist rendering of what that'll look like. This is as we're starting to expose and construct the creek a year ago. And then finally, this is what it looks like today. And again, it'll start to get a base flow as the development comes in. So just a couple tips here. I kind of mentioned this throughout, but it's really important to start early, to have a lot of planning embedded in these kinds of projects, particularly the bigger and more complicated and more stakeholders there are. It's really important to understand the regulatory framework and find where the bookends are on how far you can push that regulatory framework. Generally, we have found that can be pushed, but up to a certain limit. So a lot of engagement is important. A real critical component is early on in developing a memorandum of understanding of all parties to understand each system component and who gets to make a decision about the design and the cost, and easements and that sort of thing, and eventually operations and maintenance, which is really critical. And finally, depending on the stakeholders, it's really important to identify goals and demonstrate the cost benefit and identify which benefits are most important by stakeholder. And developing a phasing plan is really critical to really ties in to the overall financing for the site. And finally, planning for flexibility on the site in the system, maybe giving yourself a little bit of cushion on the sizing, so that if a development comes in with a higher level of imperviousness, more hardscape than planned, that you have the treatment capacity built in. So build in a buffer wherever you can. I want to thank you for listening to the presentation. I'd be happy to answer any questions if you if you have them, you feel free to reach out to me at any time. My email is listed here on this slide. Have a great day.